We are discussing corresponding angles, alternate angles, and coterminal angles. Let's suppose we have got a line denoted by L1 and another line L2 such that line L1 is parallel to the line L2. And there is another line L for example, that intersects the lines L1 and L2. This line L is called a transversal. It is a line that intersects these two parallel lines L1 and L2. Now, if we have got the angles, let me label them as 1, 2, 3, and 4. Similarly, 5, 6, 7, and 8. Now I define interior angles. The angles that lie within these parallel lines, inside of these parallel lines, are called interior angles. So the interior angles in this case are angle 1, angle 2, angle 7, and angle 8. And if I define the exterior angles, these are the angles that are formed on the outer side of these parallel lines. So the exterior angles are angle 3, angle 4, angle 5, and angle 6. Now, when we define the corresponding angles, these are the angles which satisfy uh, these three properties. The first one, that these should be non-adjacent to each other. Second one is these should be on the same side of the transversal line L. And one should be an exterior angle, other should be an interior angle. So let's take, for example, an angle 8 and let us find out the angle corresponding to angle 8. Okay, when you talk about non-adjacent, angle 7 and angle 5, these are attached to angle 8. Angle 7 is tied to this side and angle 5 is tied to this side. So these are vanished. Like that means angle 7 and angle 5 cannot be the corresponding angles to angle 8. Okay. Then on the same side of line L, since angle 8 is lying on the left side, so angle 3, angle 2, and angle 6, these cannot be the corresponding angles to angle 8. Then the third condition, one exterior and the other interior. Since angle 8 is itself an interior angle, so angle 1 cannot be the corresponding angle to angle 8. So we are left with only one possibility, that is angle 4. So angle 8 equals to angle 4 because these both are the corresponding angles. So this is how we find out the corresponding angles. Okay, let's find out corresponding angle to angle 6, for example. Okay, applying the same three conditions. Uh, Let me have, when you talk about angle 6, non-adjacent, the first thing. So angle 7 and angle 5, both are ruled out. Then on the same side of the transversal L, since angle 6 is lying on the right side of this transversal, so angle 8 cannot be the case, 1 and angle 4 are ruled out. Then one exterior and the other interior. Since angle 6 is lying outside of the parallel lines, it is the exterior angle. So its corresponding angle will be angle 2, since angle 3 being the exterior angle is ruled out. So we can say that angle 6 is equal to angle 2 because of the corresponding angles. So these were the two examples of corresponding angles. Let's uh, define and label the corresponding angles to the other angles. Okay. When we talk about angle 7, its corresponding angle will be angle 3. Why? Because both are non-adjacent. These are not interconnected. Okay. On the same side of the transversal L, angle 7 is lying on the right. Angle 3 is also lying on the right. Then one exterior and other interior. Angle 7 is an interior angle. Angle 3 is an exterior angle. So these three are the pairs of corresponding angles. In the same way, we can find out the corresponding angles to any other angle given in the question. Okay. Then alternate angles. Uh, One thing to note mm, of these corresponding angles, normally we get an F for these corresponding angles, something like this. Okay. For alternate angles, the three conditions are actually being non-adjacent, then uh, on opposite sides of transversal L, and then both interior or both exterior. That means it has got both the possibilities. Either Both the angles could be interior or both could be exterior angles. So let's try to find out alternate angles to angle 8, for example. I'm considering the same angle 8. Okay, angle 8. Non-adjacent. 7 and 5 are ruled out. Then on opposite sides of line L, since 8 is lying on the left side, the alternate angle will be on the right side. That means angle 1 and angle 4. Both are ruled out. Then the third condition, both interior or both exterior. Since angle 8 itself is interior angle, so we rule out exterior angles like angle 3 is ruled out, angle 6 is ruled out. So alternate angle to angle 8 is angle 2. So that is equal to angle 2 because these are alternate angles. So this is how we find out the alternate angles. Okay, then uh, let's find out alternate angle to angle 6, for example. Angle 6 is an angle that is lying on the outer side of these parallel lines, so that's why it is an exterior angle. Okay, it should be having an alternate angle which is non-adjacent. Angle 6, that means it cannot have angle 7 or angle 5. Then on opposite side of the transversal L. Since angle 6 is lying on the right side of the transversal, so angle 2 and angle 3 are ruled out as well. Okay, then both interior or both exterior. Since angle 6 is lying on the outer side, so its alternate angle should be lying on the exterior side as well. So these 8 and angle 2, which are the interior angles, are ruled out. So angle 6 is having angle 4 as its pair of alternate angle. So in the same way, we can do it for angle 7 as well and for rest of the angles. And one thing, whenever to find out these alternate angles, normally a Z is being formed like this for alternate angles. Okay. And for uh, coterminal angles, if I define what about the coterminal angles, uh, actually you need to see that the word co-terminal means having terminals which are corresponding or which correspond to each other. Okay. That means these are the angles that share a common terminal side and are in standard position, meaning the initial side is on the positive x-axis. So this would be, you can also say, for example, we have got the angles which are coterminal to each other, like their sum is equal to 180 degrees. When you talk about angle 7 and angle 2, their sum is equal to 180 degrees, being on the same side. They share the common side of this transversal. So these are the coterminal angles. Similarly, angle 8 and angle 1 are coterminal angles. These are also known as co-interior angles. Similarly, you can say that these angles add up to give you 180 degrees, and these are lying on the interior side of the parallel lines. So that's why these are coterminal angles. These are also known as co-interior angles. Co-interior angles, sum is equal to 180 degrees. So in this case, we are having angle 7 and angle 2. Their sum is equal to 180 degrees. Similarly, another pair is angle 8 and angle 1. So these are the co-interior angles.